All right, so let's dive into the world of distributed systems. These massive systems where tasks are spread out across a whole bunch of different computers. Now, getting them all to work together efficiently is a huge challenge, and that's exactly where process management comes into play. You can think of it as a secret sauce that makes these incredibly complex systems not just work, but work really, really well.
So, here's what we're going to cover. We'll start with the fundamentals of process management, then jump into a really powerful technique called process migration. We'll look at why it's so useful, how it actually works, and of course, the pros and cons. And to top it all off, we'll wrap up with a quick summary that's absolutely perfect for your exam prep.
Okay, first things first. What are we even talking about when we say process management in a distributed system? Let's break it down.
At its heart, a process is just a program that's currently running. Simple enough, right? Now, on your personal computer, all those processes are like workers in a single factory. But in a distributed system, it's totally different. It's like having those workers in different factories, maybe even in different countries, all having to communicate and cooperate on the same big project. And that's the key idea.
And that's exactly what process management does. It acts as the project manager for all those scattered workers. It's in charge of everything, creating new processes, deciding what they should work on and when, that's scheduling, and, crucially, making sure they can all talk to each other to get the job done smoothly. So, why go through all this trouble? Well, it's all about solving some key challenges. We want to make sure we're using all our computer power efficiently. We definitely want to avoid a situation where one machine is completely overloaded while others are just sitting idle. The ultimate goal here is to squeeze every last drop of performance out of the entire system.
Now, with those objectives in mind, let's explore one of the coolest and most powerful tools we have in our process management toolbox, something called process migration.
The key phrase to lock onto here is during execution. This is huge. We're not just talking about stopping a program on one computer and restarting it somewhere else. No, this is way more sophisticated. Imagine being able to pick up a worker mid-task with all their tools and materials and instantly teleport them to another factory where they continue from the exact point they left off. That's the magic of process migration. And that probably gets you thinking, right? Why would you go through all that effort? I mean, moving a live, running process sounds pretty complex. What's the real payoff?
Well, it turns out there are 4 main drivers behind it, and each one is focused on making the distributed system smarter, more efficient, and more robust.
First up is load balancing. If one machine is getting totally swamped with work while another is just kicking back, you can move a process over to even things out. Second is fault tolerance. If the system predicts a machine is about to fail, it can be smart and proactively move critical processes to a safer machine. Third is resource utilization. Maybe a process suddenly needs more memory or a faster CPU. You can just move it to a machine that has what it needs. And finally, there's system maintenance. If you need to take a server down for an update, you can migrate all its processes away, do your work, and then move them back, all without anyone noticing a disruption. Okay, so we've covered the why. Now for the how. How does this whole migration thing actually happen? Let's walk through the 5-step procedure.
It all starts with selecting the right process to move. Then, the system takes a complete snapshot of its current state, and I mean everything. What's in its memory, the data in its CPU registers, which is kind of like the processor's short-term memory. This entire snapshot is then packed up and sent over to the new machine. That machine uses the snapshot to perfectly recreate the process. And finally, the process is resumed, picking up exactly where it was paused. And this table shows the perfect example of the most common use case. Imagine server A is really struggling under a heavy load, but server B is pretty much idle. The system identifies a process on server A, migrates it over to server B, and boom, the load is now balanced. Both servers are working efficiently, and the performance of the whole system gets a boost.
Of course, a technique this powerful doesn't come for free. It's really important to have a balanced view and understand the trade-offs involved.
The upsides are pretty clear: better performance, better reliability, and smarter use of resources. But there are some downsides. Moving all that process data can put a strain on the network, creating high communication overhead. It's also technically very complex to implement correctly. And there's usually a tiny delay while the process is being moved, which could be a problem for really time-sensitive applications.
All right, let's pull all this together and switch into exam prep mode. If you get a 10-mark question on process migration, this is how you want to frame your answer.
You want to lead with a strong, clear definition. You can say something like, process migration is the mechanism that allows a running process to move between machines. Its purpose is to dynamically optimize the system by improving load balancing, making better use of available resources, and increasing overall system reliability and fault tolerance.
And to make sure those key reasons really stick in your head, especially under the pressure of an exam, here's a super simple memory aid. Just remember the acronym LFMS. L is for load balancing, F is for fault tolerance, M is for maintenance, and S is for system resource utilization. LFMS. It's an easy way to recall exactly why process migration is such a critical and powerful tool for building resilient, high-performance distributed systems.